Okay, we're continuing our review with template 2A. So we're starting the material now from test 2. All right, so that began with rational expressions. So here we go. We're reducing rational expressions. All right, so let's look at this one. We reduce rational expressions by factoring and crossing off common factors. We can factor the numerator just by pulling out an x squared. And we're left with 25 x squared minus 2 in parentheses. And here we have a 5x squared. So we can just cancel out x squared from numerator and denominator, and we have 25x squared minus 2 over 5. And that's reduced. Now be careful not to do any canceling here, because 5 does not divide into the numerator. 5 doesn't divide into both terms. 5 doesn't divide into 2. So that's it. There's no more canceling. This is completely reduced. Here we have another rational expression that we want to reduce. So we're going to factor numerator and denominator. All right, let's do that. Let's factor the numerator and denominator. They're both quadratics, simple quadratics. Here we have xx, and here we'll put a 3 and a 2, and everything is positive. Let's make sure we have the right middle term. 2x plus 3x is 5x, so that's correct. Now let's factor the denominator, xx. This is negative, so our signs are going to be different. And let's try 5 times 3. Okay, we want to get a minus 2x in the middle, so let's try this, a minus 5 and a plus 3. Okay, check to see if we get that middle term minus 2x by doing outer plus inner. So we have minus 5x plus 3x is a minus 2x, so that's correct. All right, so we see we have the same factor, x plus 3, top and bottom. Let's just cross those off. And this reduces to x plus 2 over x minus 5. Okay, in number 3, we're multiplying two rational expressions. And before we multiply, we like to make things a little simpler by reducing wherever we can. So again, we're going to factor and reduce. All right, so let's factor 25 minus x squared. I'll just write the factorization on top. That's 5 minus x times 5 plus x. All right, and let's see, we can factor 10 plus 5x just by pulling out a 5. So we have 5 times 2 plus x. All right, now let's factor this quadratic. Okay, so let's see, we'll put xx, and we'll try 5 times 2, 1 positive, 1 negative, and we want to get that minus 3x in the middle. Okay, so let's try minus 5 plus 2. Check the middle term. Let's see. We have minus 5x plus 2x, that's a minus 3x. Okay, let's see. So let's start our canceling. Well, here we have an x minus 5 and a 5 minus x. Since these are subtractions in opposite order, we can cancel, but we must remember to replace with a minus 1. All right, now here we have a 2 plus x and an x plus 2. These are additions in opposite order, so we can just cancel these, and these are actually the same because you can add in either order. No replacing with minus 1 here, only the subtractions that are in opposite order. Okay, what else? Let's see, I see a 5 and a 10, so let's just reduce that. Divide by 5. And I think that's it. What do we have left in the numerator? We have minus 1 times 5 plus x. And in the denominator, I just see a 2. Okay, now we have a division problem. So remember that the way we divide is we take the reciprocal of the second fraction or of the divisor and we change to a multiplication. All right, so let's do that. So here we'll have 25x cubed 3x plus 12. And now I'm going to just take the reciprocal. All right, now we're ready to factor wherever we can. All right, so here I can pull out a 3. 3x plus 4. And here we can pull out an x. Okay, so let's start our canceling. I see an x plus 4 and an x plus 4. All right, let's see. Here we have an x to the 4th. So let's cancel that. Here we will be left with x cubed. Here we have a 5 and a 25. So let's divide by 5. We're left with a 5 up here. And here I see an x cubed and an x cubed. So let's just cancel that. All right, let's look carefully. What are we left with? Well, I see a 5 in the numerator and a 3 in the denominator. So I think that's just 5 over 3. In number 5, we're subtracting two algebraic fractions, or two rational expressions, and we have to get a common denominator. So in this case, the common denominator is just the product of the two denominators. Okay, so we have the common denominator 5 times x plus 7. All right, to change this fraction to this common denominator, we have to multiply by x plus 7. Numerator and denominator. And to change this fraction, we have to multiply by 5, numerator and denominator. All right, so in this numerator, we have x plus 7 times x. That would be x squared plus 7x. And here we have 3 times 5, that's 15. And now we're just going to subtract those numerators. We don't have like terms here, so basically we're just putting everything on top of one numerator. And that's it. All right, another addition of algebraic fractions or addition of rational expressions. All right, we need a common denominator. All right, let's set this up. Let's look at these denominators. First, look at the coefficients, 5, 10, and 15. So what's the smallest number that 5 divides into, 10 divides into, and 15 divides into? Okay, so that would be 30. And now for the powers of x, just take the biggest one, so that would be x to the 4th. So 30x to the 4th is the common denominator. All right, in order to change this to an equivalent fraction with this denominator, we will have to multiply by 6. That's it, just by 6, numerator and denominator. Okay, here we have to multiply by 3x, numerator and denominator. And here we have to multiply by 2x squared. Okay, numerator and denominator. All right, so this denominator is 6 times 2, that's 12. Sorry, this numerator. This numerator is 3x times 3, that's 9x. And this numerator is 2x squared times 4, that's 8x squared. And now let's add those together Now notice that we do not have any like terms, so we're basically just putting everything on top of one numerator. Please be careful not to add terms when they're not like terms. Here again we're going to add two rational expressions, but this time in order to get a common denominator we're going to have to factor because these denominators do factor. In the previous examples we didn't have denominators that were factorable. All right, just this one over here we can pull out an x. So here we have x times x plus 1. All right, so let's look at our two denominators. We have x times x plus 1 and we have x squared. All right, we have to put together a common denominator. So the different factors are, well, here we have an x, here we have an x plus 1, and here we have x to the exponent 2. So the factors are x and x plus 1, and we have to take each factor to the largest exponent that it appears. All right, so that would be, for x we'll put x squared, and x plus 1 only appears to the exponent 1. So this is the common denominator, x squared times x plus 1. All right, to change this to the common denominator, we have to multiply by x, top and bottom. And here we have to multiply by x plus 1, top and bottom. Okay, x times this numerator, that would give us x squared minus x. And here, multiply through, we have 3x plus 3. Okay, here's the denominator, x squared, x plus 1. In the numerator, we do have some like terms when we combine these. All right, let's see, we have x squared, then we have minus x plus 3x. Okay, that's a plus 2x. And then we have this plus 3. Number 8, we have what we call a mixed quotient. We have fractions within a big fraction. We want to get rid of these denominators, the 4x and the 2x squared. So we're going to multiply top and bottom by the common denominator of 4x and 2x squared, which is 4x squared. All right, and when we multiply top and bottom by 4x squared, these denominators will cancel. So that's 4x squared over 1. We write 4x squared in fraction form over 1 just so things line up nicely. Now I like to first do the distributive law and then cancel in the next step. So I'm putting 4x squared over 1 next to this fraction, just multiplying through, plus 4x squared times 5, that's 20x squared. All right, so we just did the distributive law over there. And now same thing in the denominator. Okay, 4x squared times 7, I'll write 28x squared. And here I'm just going to write the fractions next to each other. Minus 1 over 2x squared, and then 4x squared over 1. All right, and now we're going to divide. So here we're just going to cancel out these 4's. And here we have xx squared. We're left with x. All right, here 2 into 4, we're left with 2 here. And these x squares cancel. All right, so let's look carefully, see what we have left. We have 3x plus 20x squared. And here we have 28x squared minus 2. Okay. So we've simplified the mixed quotient.